Hello everyone, in this lesson we are going to focus on the projectile motion and we are going to solve some examples about projectile motion. Let's start with the first example. Which of the following is not true about the path of a cannonball launched horizontally from the Earth's surface if air resistance is neglected? Let's first draw the picture of the motion. Let's say this is the cannonball. It's projected horizontally with a velocity of v0. And it's moved like this. It's the cannonball. Choice A, the cannonball has a uniform horizontal velocity. Since it's projected horizontally, the vertical velocity, the vertical component of the velocity is 0. And the horizontal component of the velocity is equal to initial velocity. The horizontal component of the velocity is equal to the initial velocity and it's always constant along the motion. At this point, it's also v0 x. So option A is correct. B, the total velocity of the cannonball increases as a function of time. Total velocity of the cannonball increases as a function of time. That's right also because the vertical component at the beginning start to increase like this. This is the vertical component of velocity. Let's say it's v0 y. And it's maximum at this point. So the option B is correct also. The vertical velocity of cannonball increases as a function of time. Yes, that's right, as you can see here. Option C is also correct. The distance the cannonball travels only depends upon the height it is shot from. The height of the cannonball determines the flight time. When the height of the cannonball increases, the flight time increases, so the distance increases. That means the distance the cannonball travels only depends upon the height it is shot from is correct also. E, the distance the cannonball travels is dependent on its mass. The distance the cannonball travels is dependent on its mass. No, this is not correct. Option E is not true. Now let's go to the next question. This is the second question. A ball on a table of height 2 meters is rolled off with a velocity of 5 meters per second. How much time does it take for the ball to hit the ground? Neglect air resistance. Let's first draw the picture of motion. There's a table. This is a table. height of the table is 2 meters. So it is 2 meters. And it says it's rolled off. That means it's projected horizontally with a velocity of 5 meters per second. How much time does it take for the ball to hit the ground? Then it will travel approximately like this. How much time? From the equations of projectile motion, we know that height is equal to vertical component of velocity times t minus 1 over 2 g t square. And the height of table is 2 meters. That means it's negative 2 because it's below the reference point. So negative 2 is equal to initial velocity, the vertical component is 0 minus 1 over 2 times 10 times t squared. Then minus 2 is equal to minus 5 t square, which implies that t square, which implies that t square is equal to 2 over 5. Then time is equal to square root of 2 divided by 5. That's the answer. Of course, this is second. This is the flight time.